Start with the name of Allah, who is the most beneficent and the most merciful. Today's topic is isotope, the hidden version of the elements. Before moving to the topic, did you solve this puzzle? If yes, then pause the video and check your answer. Here is the answer of that puzzle. So let's move to our main topic, that is isotope. Isotope is actually a combination of two words, iso and tops. Iso means same and tops mean position. So isotopes are like the elements of the same atom. They have same position in the periodic table. They are like siblings. Isotopes of the same elements are like siblings. They have same surname, but their first name is different, like their personalities. So in the same way, isotopes are also have some similarities with some differences. In which way they are same and in which way they are different. So they are same according to the number of protons, but they are different according to the number of neutrons. Here is a simple definition. Atoms of the same elements, the atoms of same elements having different number of neutrons. So the number of neutron is basically the atomic mass. So they have different number of neutrons in their nuclei. Or in other way, atoms which have same atomic number but different mass number are called isotopes. Now the same atomic number means they have same number of protons, and different mass number means they have different number of neutrons. So the elements that have more number of neutrons are actually more heavier than the isotopes of the element that have lower number of neutrons. Here is some examples for the isotopes. Like isotope of hydrogen, we have different elements have different number of isotopes. Like hydrogen has 3 isotopes, carbon has also 3 isotopes, and chlorine has 2 isotopes. Now we will move to these isotopes, like the isotopes of hydrogen. We already learned that the isotope of hydrogen has 3 isotopes. These are named as hydrogen, deuterium, and tritium. Their structure is as follow. Like protium. Protium is the isotope that have 1 electron, 1 proton, and 0 neutron. So the hydrogen H1 they are also represented as H1, means they have 1 atomic number and 1 mass number. So it has only 1 proton inside the nucleus and 1 electron outside the nucleus, while the deuterium has 2. It has 2 atomic number. So it has 2 mass number. It has 1 proton, 1 neutron, and 1 electron, while tritium has 2 neutrons, 1 proton, and 1 electron. So in these isotopes, only the number of proton is changing. The first protium has 0 neutron, while deuterium has 1 neutron, while tritium has 2 neutrons. In these neutrons, hydrogen is the only atom which does not have a neutron. Hydrogen H1. H1 is the only atom in the periodic table which does not have a neutron, like as shown in the diagram. Next is the isotopes of carbon. Carbon also has 3 isotopes that are named as carbon 12, carbon 13, and carbon 14. And these are their atomic masses. Carbon 12 means they have 12 atomic mass, carbon 13 they have 13 atomic mass, and carbon 14 they have 14 atomic mass. And here is the diagram for the isotopes of carbon. Like carbon 12, it has 6 electrons, 6 protons, and 6 neutrons. These blue colors are showing the electrons, while inside the nucleus we have protons and neutrons. So it has 6 protons. So it has 6 protons and 6 neutrons. So the overall atomic mass and atomic number is, the atomic mass is 12 and the atomic number is 6. While the carbon 13 has 7 neutrons. It has same number of electrons and same number of protons, but the neutron number is different. It has 7, while the carbon 14 has 8 neutrons. These two are stable, while the carbon 14 is radioactive. How they are stable and how they are radioactive? So in simply, neutrons are like the nuclear glue. They hold the atoms together. They hold the subatomic particles inside the nucleus together. Some combinations are very stable, so they make the atoms stable, while some combinations are not stable. They decay over the time, so that combinations which decay over the time are known as the radioactive. Here are some similarities and dissimilarities between the isotopes. Like, first we'll focus on the similarities. So which things that are same in the isotopes of the same elements? Like, they have same atomic number, means same number of protons, and they have same chemical properties. How they have same chemical properties? Because they have same number of protons, and same number of protons means same number of electrons. And the chemical properties basically depends on the number of electrons. Upon the shell structure, the elements, the electrons present inside the valence shell. So the valence shell of all the isotopes of the same elements have same structure, so their chemical properties is also same. While their dissimilarities are like, they have different mass number. Mass number are actually what? Mass number is a combination of protons and neutrons. So they have same number of protons, but in case of neutrons, they have different number of neutrons. So when they have different number of neutrons, so the automatically the mass of the atom will be changed. So their mass number is different, and their physical properties are also different. Why their physical properties are different? Because the physical properties depend upon the mass. Heavier the mass, heavier will be the atom, and the weight is also the physical properties. So the as the neutrons in the atom increases, the mass of the atom will also increase. So the mass increase, the physical properties will be changed. Here's a question: why the isotopes of the same elements show same chemical properties but different physical properties? So first of all, we must know about the physical properties and the chemical properties. So chemical properties are those properties that are related with their chemical reactions, while the physical properties are those properties that are associated with their physical appearances, like their appearance, their taste, their color, their shape. So these are the physical properties. As we already know, that the chemical properties depend upon the number of electrons. So isotopes have same number of electrons and same number of protons, so their chemical properties remain same, while physical properties depend upon the mass number, so their physical properties change as the mass of the isotope change. At the start of the lecture, we have studied that the isotopes means, isotope mean the atoms of the same elements remain in the same position, means they have same position in the periodic table. Like the three isotopes we have learned for hydrogen. Hydrogen is the first element in the periodic table. So we know that a hydrogen has three isotopes: H1. Hydrogen has three isotopes: H1, H2, and H3. So these three isotopes remain in the same position here. At the first position are the first block in the periodic table. So all the isotopes of the same elements remain in the same position in the periodic table. Like the carbon, we also learned that carbon has three isotopes: carbon 12, carbon 13, and carbon 14. So these three isotopes of carbon also remain in this position, in the 12th position of the periodic table. In the same way, chlorine has two isotopes, chlorine 35 and chlorine 37. So these also remain in the same position position number 17. So this is simply the simply a simple explanation for the isotopes, how they are different and how they are same. Um, till yet we have learned about the isotopes. What are isotopes? How they are different and how they are same? Which factors make them different? Which factors make them similar? And why they have same chemical properties and different physical properties and their position in the periodic table? All these factors we have learned now. The next topic is the radioactive isotopes and the stable unstable reactivity, unreactivity, stability of the isotopes. That topic we will discuss in the next video. Till that, thank you. Allah Hafiz, and stay tuned and connected with this YouTube channel. Kindly subscribe and press the bell icon button. Thank you.